This video is also from a problem from Chapter 2 in Math Excel, and so we'll take a look at it. Oh, we've got a whole different set of topics here. And so the question is this particular number, and the number they've given us is 1, but is it a prime number, a composite number, or neither? All right, so let's see if we can understand a little more about what they mean by prime, composite, or neither. We might get some help from the question help. Let's see what the question help says here. I mean, we'll just use what they're doing. Okay, so let's see here. Okay, so here's their definition for a prime number. Okay, a number is prime if it has exactly 2 different factors, just itself and 1. Okay, so that's the definition of a prime number. It has exactly 2 different factors, itself and 1. All right. And we have some other, in their example, we have some other factors. Oh, so in other words, if it's not prime, it must be composite. If it's not prime or composite, it's a neither. All right, and we're going to learn somewhere along the way that 1 and 0 are considered to be neithers. And it really has to do with 1 doesn't have other factors other than 1, but it doesn't have anything other than 1. You with me? So that, another way to say it is that for a number to be a prime number, it must have 2 divisors, and 1 only has 1 divisor. It doesn't have anything else you can multiply times 1 to get 1. 0 is the same case. There's, you got to have 0. Now you might say to yourself, well, wait a minute now, 1 times 0 is 0. But generally we classify both 1 and 0 as neithers. All right. But anyhow, so in this case, this particular example, determine whether the following number is prime, composite, or neither. Okay, it's going to be a neither. And we only got one final check here. I'm pretty sure that's what they want. Now, before we go to the next question, why don't we see what we can learn from what we've already done on a previous problem? You ready? Remember okay, so here, let's review. A prime number has only, has only 2 factors, itself and 1. Only 2 factors. A composite number has more factors. More factors what? More factors than this situation. And a neither, well, we've already said that 1 is a neither because 1 only has itself and 1. 1 times 1. Now, what's 0? Let's talk about 0 for a second. If I ask you to get 0, give me the factors of 0. Well, the factors of 0 are just 1 times 0. Right? 1 times 0 is 0. Well, wait a minute. What about 2 times 0? What about 3 times 0? What about 4 times 0? Oh, okay, so it's so weird. Anything times 0 is going to be 0. So it kind of blows out our whole idea of this factorization stuff. And you'll notice that in the material, what they've done is they've defined factors to be natural numbers. Natural numbers. Okay, do you remember what a natural number is? A natural number is the counting numbers. And it's kind of like if you had your hand here and you start counting 1, 2, 3, 4, 5. In the natural numbers and the counting numbers, 0 is excluded. Okay, so in this whole conversation about factors, we just kind of don't worry about 0 being in there because it's such an oddball. Then, say, well, where are you trying to go with this? I'm going to take this example we did from before, which was 250, and I'm going to show you another idea for how to determine the factors of a value. I'm going to start off with 250, and I'm going to use only prime numbers. I'm only use only prime numbers in my factorization. What are prime numbers? Well, let's write some down. 2, 3, 5, 7, not 8, not 9, but 11, 13, yes. That's enough for this. 1 times 2 is 2, only way you can get it. 1 times 3 is 3, only way you can get it. 1 time, and so forth. You see that? So what I'm going to do is I'm going to do this. I'm going to start off with the lowest prime number. This is the classical way you do this. I'm going to start off with the lowest prime number, which is 2. And we already know that 2 times 125 is 250. That's a prime number. I'm not going to use it anymore. Now, will 2 go into 125? No. Will 3 go into 125? No. Will 5 go into 125? I think it will. 525. Prime number. 25 is not a prime number. 5 times 5. So now, please don't get confused. The prime number factorization of 250, the prime number factorization. If they said make it a prime number factorization, we would have 2 times 5 times 5 times 5, okay? Now, and generally, just to be clear, we simply do this. We simply say, oh, this is 2 times 5 times 5 times 5. And how do you use that? Well, you check it. You multiply 2 times 5 is 10, times 5 is 50, times 5 is, well, we didn't have another one, did we? It's 250. Now, you're saying, yeah, but I don't understand something. A minute ago, we had all those other factors up there. Remember what we had a few minutes ago? We had all these other factors. We had 1, 2, 5, 10, 25, 50, 125 to get to 250. Well, you can find every one of these in here. Here's 2. All right, okay, so my screen's getting in the way a little bit here. So you can find 2. Here's 2. Here's 2. 5. Here's 5. 2 times 5 is 10. There's 10. 5 times 5 is 25. There's 25. Okay, and so then 2 times 5 is 10 times 5 is 50. And then how can we get 125 out of this thing? So let's see. 5 times 5 is 25 times 5 is 125. And then 2 times all that mess is 250. Okay? So there's 2 ideas. This is where you're going to list all the factors. This is where you're going to only find the prime number factorization. And in this one, you're only going to use prime numbers. Now, the last thing I'm going to say about this is that every number has a unique prime number factorization. Individual, unique to itself. Okay. We've already finished that, so I think we'll call this done.